Good morning, student. Welcome, student, for this mathematical method lecture for physics. Topic is differential equation. This differential equation help all student many exam, SET exam, BSc exam, MSc exam. So differential equation very important in various exam. So differential equation here discuss second order linear differential equation. Now here start lecture. Sorry dear student, now start here second order linear differential equation. So differential equation is very important. All SET exam, all MSc exam, BSc exam. So now here start. Let's start here. Now today topic is second order linear differential equation. Second order linear differential equation. Second order linear differential equation. So now here second order linear differential equation. Consider a linear differential equation Consider a linear differential equation. Consider a second order linear differential equation. Consider a linear second order differential equation. B square y by dx square px into dy by dx plus qx equal qxy equal to rx. So here consider a linear differential equation. Here px and qx, here px qx are function of x. Here px and qx are function of, here px and qx and function of x, and are equal to rx. So differential equation d square upon d square y upon d square px dy upon dx qx into qx y rx. Here px qx function are of x and rx equal to rx. So here solution of the differential equation. Now solution of the differential equation. So here write down second order linear differential equation. If first condition when r equal to rx equal to here r equal to rx equal to here 0. Now here r equal to rx equal to 0. Write down that so here r equal to rx equal to 0. So 1, this is homogeneous second order linear differential equation. Homogeneous second order linear differential equation. Homogeneous second order linear differential equation. First is differential equation r is r equal to rx, so r equal to rx equal to 0. So this type of differential equation is called homogeneous second order linear differential equation. So here d square upon dx square plus px dy upon dx plus qx into y equal to 0. So this type of differential equation, homogeneous second order differential equation. I hope every student is very clearly or very understanding. So now all student is very understanding homogeneous second order differential equation. The next step is here. So here write down d square upon dx square p dy upon dx q y equal to 0. This is the second order linear, this is the homogeneous second order linear differential equation. this is the homogeneous second order linear differential equation. This is the homogeneous second order linear differential equation. Now here second order linear differential equation, how to solve. Homogeneous second order linear differential equation, how to solve here. Now so how to solve. So let's its solution, let its general solution, where let's now here let's its let its general solution. So here now let its general solution. This homogeneous second order linear differential equation, a general solution y equal to e to the power mx. Let its general solution y equal to e to the power mx. So now y equal to e to the power mx. So here differential dy upon dx. So differential e to the power mx upon e to the power mx. M is constant. Here m differential second time. So m. Now second time of differential equation, d square upon dx square, d square upon d square. So now here m, here differential e to the power mx, then second time differential m again. So m square e to the power mx. Now put this equation. Now here put this equation. So here, so I think every topic is very interesting, so clearly. So now here, put here. So d square upon dx square, d square upon d square is m square e to the power mx plus, so p dy upon dx m e to the power mx plus q e to the power mx, q e to the power mx equal to 0. So here m square pm plus q e to the power mx equal to 0. mx equal to 0. Now here so here m square pm q first bracket here e to the power mx equal to 0. Here e to the power mx not equal to 0. E to the power mx is not equal to 0 because it's because let it in general solution. Here e to the power mx is general solution, so e to the power not equal to 0. So here m square pm plus q equal to 0. So this equation is called auxiliary equation. This equation is auxiliary equation. So now here Now here this auxiliary equation solve, and then we get then we get then we gets then we gets then we gets then we get then we get two then we get two roots. Then we get two roots. Suppose two roots are we get two roots are m1 and m1 is two roots m1 and m2 so we get two roots m1 and m2. So here these roots are different type of value. These m1 m2 roots are different value, real and different, real equal value, complex conjugate value, or not complex conjugate value. So now here case 1 is here now so here roots are case 1 here case 1 if the roots are real and different, if the roots are real and different, then y then solution is for homogeneous second order linear differential equation is c1 e to the power mx plus e to the power m1x plus c2 e to the power m2x. If the roots are real and different, then complete solution. Complete solution for linear homogeneous second order linear differential equation c1 e to the power m1x plus c2 e to the power m2x. So this so next is here this solution is sometime with ci complementary integral is c1 e to the power m1x plus c2 e to the power m2x, c2 e to the power m2x. second case 2 here. Case 2. If the roots are real and equal, if the roots are real and equal, then complete solution for homogeneous second order linear differential equation. Homogeneous second order linear differential equation C1 plus C2x e to the power mx. So here m1 is value, suppose m1 value is 2, m2 value is 2. Here m1 value is 1, m2 value is 2. Roots are different, roots are equal. So case 3 here. Case 3, if the roots are complex conjugate, if the roots are complex, if the roots are complex conjugate, suppose m1 equal to alpha plus I beta, m2 equal to alpha minus I beta. So complex. So if the roots are complex conjugate, if the roots are complex conjugate, then here, so then complete solution is y e to the power alpha x c1 cos beta x plus c2 sin beta x. If the roots are complex conjugate, then if the roots are complex conjugate, m1 equal to alpha plus I beta, m2 equal to alpha minus I beta, then complete solution y e to the power alpha x c1 cos beta x plus c2 sin beta x, Here example here. So m1 is 2 plus 3i, m2 is 2 minus 3i. So if the roots are complex conjugate, m1 equal to alpha plus I beta, m2 equal to alpha minus I beta, then solution is for differential equation. Differential e to the power alpha x c1 cos beta x plus c2 sin beta x. Then fourth case is here. Then case number is 4. Then case number is 4. If the roots are if the roots are not complex conjugate, suppose m1 is m1 is alpha plus beta, m1 is alpha plus beta, m2 is alpha minus beta. Then solution is y for homogeneous second order differential equation. e to the power alpha x c1, e to the power alpha x c1 cos hyperbola beta x plus c2 sin hyperbola beta x, তাহলে so here e to the power alpha x c1 cos hyperbola beta x plus c2 sin hyperbola beta x. So for case number 4 is if the roots are not complex conjugate. Here m1 is alpha plus beta, m2 is alpha minus beta. So y e to the power alpha. So complete solution for homogeneous second order differential equation e to the power alpha x plus c1 cos hyperbola beta x plus c2 sin hyperbola beta x. So now a example here. So example here. So example here, d square y, d square, suppose a problem here, d square upon dx square, d square upon dx square plus d square upon dx square 3y, 3 into dy upon dx, dy upon dx minus 10y equal to 0. Suppose example. So here condition is here rx equal to rx equal to 0. So homogeneous second order linear differential equation. So d square upon dx square plus 3 into dy upon dx minus 10y equal to 10y equal to 0. Now so here solve here. D square 3d minus 10 equal to 0. Now first solve auxiliary equation. Now first solve auxiliary equation. From auxiliary equation we find two roots m1 and m2. Then solution is write down. So now auxiliary equation is we write. Now auxiliary equation we write m square 3m minus 10 equal to 0. So now m square (5m minus 2m) minus 10 equal to 0. So here m plus 5 minus 2 m plus 5 m plus 5 equal to 0. Now m plus 5 m minus 2 equal to 0. So here m plus 5 equal to 0, m plus 5 equal to 0, m equal to minus 5. Second is m minus 2 equal to 0, so m equal to 2. So if the roots are real and different, then complete solution here we write complete solution is right y c1 e to the power 2x plus c2 e to the power minus 5x. So here suppose c1 equal to a, c2 equal to b, constant term. So here put here c1 equal to a 2x, b e to the power minus 5x. Then this is the complete solution. A e to the power 2x, b e to the power minus 5x. So put here c1 equal to constant a, put c2 equal to constant b. Suppose solution is sometime is c1 and c2, sometime is a to b constant term, So I think understanding solve this equation. Then next question here, d square upon dx square, d square upon d square minus 3 dy upon dx minus 3 dy upon dx into 2y equal to 0. Now solve this differential equation. Basically this differential equation is homogeneous second order linear differential equation. Here we write d square minus 3 minus of 3d minus 3d plus 2y equal to 0. Now here solve auxiliary equation. Here auxiliary equation we get two roots. Then we get two roots here write m square minus 3m plus 2 equal to 0. So here m square minus 2m minus m, m square minus 2m minus m plus 2 equal to 0. So m into m minus 2 minus 1 m minus 2 equal to 0. So m minus 2, m minus 1 equal to 0. So roots are, so here roots are m minus 2 equal to 0, m equal to 2, m minus 1 equal to 0. So here m1 is 2, m2 is 1. Then complete solution here. So here complete solution, here. Then here complete solution y is complete solution is c1 e to the power m1 x plus c2 e to the power m2 x. So y equal to c1 e to the power m1 is 2x plus c2 m1 is 2, m2 is 1x. Y equal to c1 e to the power 2x plus c2 x. This is the solution of this differential equation. This differential equation means homogeneous second order linear differential equation. So next lecture here we discussion here for differential equation for homogeneous, non-homogeneous second order differential equation. Second case discuss here. Second case 2, non-homogeneous second order differential equation. Non-homogeneous second order differential equation. It means r equal to rx. So value is suppose is value e to the power mx. So not equal to 0. So here this equation is non-homogeneous second order differential equation. Non-homogeneous second order differential equation, how to solve? So wait for the second lecture. Wait for second lecture. So I think lecture is very helpful for BSc student or many set exam or other exam. So today lecture is very interesting, I think. So then next day here so well done student. Thank you very much for this video and very enjoyable this lecture. Have a good day, good morning, good evening, good night for all students. Stop now lecture here.